All right, so for those of you who are unfamiliar with trigonometric functions, some of you have probably worked on this maybe in Algebra 1, maybe you did it in geometry, but I'm going to introduce you to some of the buttons on your calculator and what they mean, the sine and the cosine and the tangent. And I'm going to play a video for you here in a second, and you can find this video in your assignment too if you want to watch it on your own. But I've used this video for many years, and I know this guy's a little bit goofy, but I'm telling you, you will remember the information, and that's important. So here we go.
1, 2, 3, 4. Sokotoa, sokotoa, sokatoa, 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 sokotoa, sokotoa, sokatoa. Sine, opposite hypotenuse, sine, opposite hypotenuse, sine.
All right, you should write this down. In your notes, sine is the opposite over the hypotenuse. And we've been talking about right triangles now, and we should have a pretty good idea what the hypotenuse is, and we'll get into what the opposite is here in a second.
Opposite hypotenuse, cosine, adjacent hypotenuse, cosine, adjacent hypotenuse.
Okay, same thing. In your notes, write cosine equals adjacent over hypotenuse.
Cosine, adjacent hypotenuse, tangent, opposite adjacent.
Same thing. Write this down. Tangent equals opposite over adjacent. And those are the three trig functions. And I'm going to let them keep singing to you, and we'll get into how you use it as well.
Tangent, opposite adjacent, tangent, opposite adjacent. The long sides of hypotenuse, and the other two sides depend.
Okay, so here's what's important. The long side is always a hypotenuse. It's always opposite from the right angle. And as he just sung, the other two sides depend. And I'll play it back again.
Long sides of hypotenuse, and the other two sides depend on which angle you're focusing on.
So again, whichever angle you're focusing on, or whichever angle you're at, if you're over here, then this is the opposite side. And adjacent, another word for adjacent is touching. So this would be the adjacent side. If I'm up here at this angle, then this side is the opposite, and this side is the adjacent. The hypotenuse is always a hypotenuse. It's never going to move. It's always directly opposite the right angle. But as he's going to go through, he's going to show you one particular angle, and then I've got another video that I'm going to show you that kind of illustrates it as well.
Pick one angle and look. There's one side that's the opposite. You can clearly see that there's also an adjacent.
One of the things I like about identifying the opposite side is if you're sort of standing at this angle, all you got to do is draw a line from the angle to the opposite side, whichever side's not being used, right? The hypotenuse is here, the adjacent side's here. You draw a line from that angle to the only other side, and that's the opposite side. That's kind of a way to think about it. And I will tell you that one of the things that you should do when you're working on these problems is identify these three sides every time, because then the rest gets easy from there. Once you know which the opposite side is, the hypotenuse is, the adjacent side is, this is pretty simple, but you got to remember which one goes to what.
Side, sine, opposite hypotenuse, sine, opposite hypotenuse, sine, opposite hypotenuse, cosine, adjacent hypotenuse, cosine, adjacent hypotenuse, cosine, adjacent hypotenuse, tangent, opposite adjacent, tangent, opposite adjacent, tangent, opposite adjacent. Sokotoa, sokotoa, sokatoa, sokotoa, sokotoa, sokatoa.
In case you haven't figured out yet, sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. That's where SOHCAHTOA comes from. That's why we use it.
Sokotoa, sokotoa, sokatoa, sokotoa, sokotoa, sokatoa, sokotoa, sokotoa, sokatoa, sokotoa, sokotoa, sokatoa.
Okay, so you're welcome to watch that video as often as you'd like, but I use it because you guys remember it. you can't forget that song. You can't forget him. And if you use that SOHCAHTOA, that will help you figure out and decide sine, cosine, or tangent, which one you're supposed to be using. Now, this next video is not nearly as entertaining, but it still has some good information in it, and I want us to watch it. Like I said, not nearly as entertaining, but it's still informational.
Hello everyone, I am Sergio Alvarez, and today we will learn trigonometric ratios. Now, before we start learning about the trigonometric ratios, we must learn a few things about this right triangle. Now, the reason I know I'm inside a right triangle is because of this little box. This little box serves as an indicator that this angle measures 90 degrees. Now, let's learn something about the sides. A right triangle has one side that is longer than the other two. Now, if you can't tell which side is longest just by looking at your right triangle, try doing this. Locate your 90-degree angle and look opposite. This side is the longest side of my right triangle. This side has a special name. It's called the hypotenuse.
Okay, now he doesn't quite pronounce it right, but don't worry about it. But what's important here is the hypotenuse is always the longest side. It's always the longest side, and it's always opposite the right angle.
Hypotenuse. 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 Now, the name of the other two sides depends on which angle we're talking about.
Okay, again, that same idea. Depending on which angle you're at, will tell you which side is opposite. If you're here, then this is the opposite side. If you're here, then that's the opposite side. So it's all about perspective. And in every one of these problems, you're going to know which angle you're talking about or which angle you're trying to figure out. And so that's really important.
Say, for example, we're talking about this green angle. If we're talking about this green angle, then this side is next to it. Another word for next to is adjacent. This side is adjacent
Next to or touching.
the green angle. This side is still your hypotenuse, which makes the bottom side opposite.
And like I said before, I typically would want to find the opposite first and then the other one's adjacent.
So there you have it. Hypotenuse, adjacent, and opposite when we're talking about the green angle. Now let's talk about the yellow angle. This side is next.
So here's where this is going to change it up now. Since I'm at this angle now, this side becomes the opposite. This one is next to it. So that's adjacent, that's opposite. So it switches because we are talking about a different angle. The hypotenuse still stays the same.
Angle, which makes this side adjacent. This side is adjacent to the yellow angle. This side is still the hypotenuse, so that makes this side opposite. This side is opposite to the yellow angle. Now we can start learning the trigonometric ratios by using an acronym to help us remember. An acronym is a word that stands for something. The acronym that we'll use is SOHCAHTOA. SOHCAHTOA.
Now, I want you to write this down too. I like the way he writes this out. Instead of writing it all out as one word, he writes it as a fraction. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And anytime you take a test or quiz on this stuff, I mean, this should be the first thing you write down. You're writing this right at the top of your page, and then you don't have to keep recalling it. It's just there. And but you got to remember it the first time. And this is another way to help you remember what goes where. I like this way. And then we're going to go through a problem. He's going to go through a problem, and we'll kind of walk through that.
So, sine of x equals the opposite side over the hypotenuse. Cosine of x equals the adjacent side over the hypotenuse. TOA. Tangent of x equals the opposite side over the adjacent side. Okay, we are ready to do some math. Now in this problem, we are asked to find the measure of the green.
Okay, so in this problem, they're going to find the measure of the angle, but we're not actually going to keep going from there. I'm going to go through and show you how to use it now. So here's the kind of situation that we're going to have. Okay, another way of looking at this problem. This little symbol here is a Greek letter theta. Okay. And so that letter represents this particular angle right here. Okay. If it was possible, they would shove it a little further to the right, but they just couldn't do that. Okay, so that's the angle that we're talking about, and this theta gets used a lot. It looks like a sort of slanted zero with a line through it. But notice if we're over here at angle B, theta, the opposite side is here, the adjacent side is here, and the hypotenuse is here. So this is, again, just another representation of what we've just been looking at. Notice over here you see this is the way your calculator looks. And you don't have to write out the whole word, okay? This is an abbreviation for sine, cosine, and tangent. This is not sin. Please don't call it sin. I know we go to a Catholic school and we talk about that, but this is sine, cosine, and tangent, okay? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, okay? Now let's go through how to find a missing side, because what's going to happen here in this first section is you're going to write ratios of these particular problems, and then day 2 you're going to find a missing side, and then day 3 we're going to find a missing angle. So today we're going to focus just on writing the ratios and coming up with those ratios. Now understand, in order to come up with those ratios, I must have these things. So I need the opposite side length, I need the adjacent side length, and I need the hypotenuse. If we can find all three of those things, we can write these three ratios. In some cases, in some of these problems, you're only going to have 2 of them, and you're going to have to find the other one. Well, that's the reason why we spent last week working on Pythagorean theorem, because when we're only given 2 of the sides, we have to find the third side using Pythagorean theorem. Then we'll have all 3 sides. So here's the type of problem that you're going to and I'll just tell you, they're the reciprocals of these. Just flip them all and you get another 3, and I'm not going to tell you what they are because they're just, we won't use them very often. See. All right, so here's the first one. Find the values of the 3 trigonometric functions. Oh, that reminds me. In your homework, it's going to say 6. There are actually 6 trigonometric functions. I'm only teaching you 3 because those are the 3 that we really use the most. The other 3, but when you're doing your homework, when it says find the values of the 6, I only want 3. Sine, cosine, tangent. That's it. Okay. So we look over here at this problem. Here's my angle theta. I have this side 17, this side 15. I'm missing the side over here. So what I like to do first is identify the opposite, adjacent, and hypotenuse of my triangle, and then it's just a matter of plugging them in and seeing what we've got. So since this is my right angle, the hypotenuse has to be opposite. So this has to be the hypotenuse. Now, for the opposite and adjacent, we have to figure out where we're sort of standing. I'm standing over here. So the opposite, if I just drew a line to it, would be over here. So this is the opposite side, which makes this the adjacent. And I like to label it. So what I'm looking for in this case is this opposite side. So this is the opposite side over here. And that's also the side I need to find. Okay. The other thing to think about is, since I have the adjacent side and I have the hypotenuse, I actually have one of the 3 trig functions. Because which trig function uses adjacent and hypotenuse? Hopefully you figured that out. If you said cosine, then you'd be correct. So cosine of theta is 15 over 17. Because that's the adjacent over the hypotenuse. So that one's already done. So all I need is 2 more. But in order to find those 2 other ones, I need this opposite side, because sine is opposite over hypotenuse and tangent is opposite over adjacent. So in order to find this opposite side, I have to use the Pythagorean theorem to find this side. Since I have the hypotenuse, am I going to add or subtract under the radical? Hopefully you said subtract. So I have 17 squared, the hypotenuse, minus 15 squared. And when I calculate that, go plug that in, see what you get. You'll see that the opposite side is 8, and I've replaced that over here. So now I have my opposite side, which means I can find the sine and I can find the tangent. So the sine is going to be 8 over 17, and the tangent is going to be 8 over 15. So once I have all of those things, once I have all three parts, it's just a matter of plugging in sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. And these are my values. These are the ratios. When you reduce, whenever possible, you need to reduce. Just like with any fraction, you should always reduce it down. Do not express it as a decimal. I want it written as a ratio, written as a fraction. And that's all there is to it. So we're going to take what we were working on with the Pythagorean theorem. We're going to apply some new stuff to it, this opposite, adjacent, hypotenuse. But then, writing things as a fraction, it's not too bad. Sometimes problems are going to be a little trickier. Okay. In this case, they actually give us sine of b. They tell us what the sine is. Find the exact values of the other two. Exact values mean fractions. Mean reduce your fractions. So since I already have the sine, I need to find the cosine and the tangent. Well, here's the way I like to think of this. And I would, if I were you, draw a picture. And it doesn't have to be a fancy picture, just a picture of a right triangle. Because I think that helps us see what sides we have, what sides we're given, what side we need to find. So the key thing is that since they're giving me the opposite side, since it's sine and the hypotenuse, I know the hypotenuse and I know the opposite side. I need to find the adjacent side. So here's what a picture might look like. So here's angle B. So if we're standing over here, my opposite side is 5, the hypotenuse is 8. I don't have this lowercase a, which is adjacent. And just for future reference, as we get more into this, and we typically label angles with capital letters and their opposite sides with the lowercase. So this is lowercase a, this would actually be lowercase b, and this would be lowercase c over here. So I need to find a, and we want exact values, which means no decimals. Okay. So again, I have the hypotenuse. So in order to find a, I'm going to have to use the Pythagorean theorem, and I'm going to have to subtract. So what I have here is a is the square root of 8 squared, the hypotenuse squared, minus 5 squared. And that actually ends up giving me the square root of negative 39. And here's where the exact value thing comes in. This is not a perfect square. So if you tried to plug this in your calculator, you got some decimal that went on and on and on forever, which is not what we want. Exact values mean use the radical as it is. Okay? Because since this is a decimal goes on and on forever, whatever decimal point you stopped with would be an estimation. You rounded. It's not exact. So what's important here is to keep it as a radical. Now, fortunately for us, we have the adjacent side, so I can find the cosine, I can find the tangent, and we just plug these three things in, and we're good to go. Okay, so for the cosine, again, we're looking for the cosine and the tangent. That's what's left. We already have the sine. We're looking for the cosine of b and the tangent of b. So in this case, the adjacent side is a, what we just found. So that's the square root of 39 over the hypotenuse, which is 8. Then for the tangent, I go opposite over adjacent. So 5 over the square root of 39. So here are my two remaining trigonometric functions. Okay, cosine of b adjacent over hypotenuse. Maybe it'd be helpful if I wrote this square root of 39 right in there, because in reality that's what this is, right? This value goes there. Okay, so again, I've got adjacent over hypotenuse, so there's my cosine, opposite over adjacent. Now, here's one issue, and this has been a little while since we've worked on this. I don't want to say it was chapter 5, but one of the things that we have to watch out for is radicals and denominators. We're not allowed to have those. Remember, we're not allowed to have a radical in the denominator, and we had to rationalize it. And the way that we did that is we just multiplied the top and the bottom by it, because essentially what we're going to do is square it. And squaring and square root will just cancel each other out. So all I have to do is multiply the top and bottom by the square root of 39, and then this radical on the bottom will go away. Because the square root of 39 squared is just 39. So I've got 5 times the square root of 39 over 39. Now I don't have a radical on the bottom, and these two are done. Exact values, no decimals, no radicals in the bottom, and we're in good shape. Okay, so this is about as hard as it'll get. Most of the problems will be like what you did earlier, the previous example.